Now we're going to look at two strategies to solve these double-digit math problems that we're looking at. Right now we're only talking about adding double digits together. We aren't quite ready for subtraction yet. Right now I showed you how to do a proof drawing, and every time you're doing any kind of double-digit problem you will always be asked to do a proof drawing. Sometimes you might want to do your proof drawing first and then do your strategy, or you might like to do your strategy first and then do your proof drawing to check to see if your sum is or your total is correct. Being able to do a proof drawing provides you with a way of doing a double check. It also shows on a deeper way your understanding of what you're doing when you're joining these numbers together. I'm going to show you two strategies today for adding double-digit numbers. The first one is called all totals. The second one is called expanded. Okay? We're going to have two double-digit numbers, so there's going to be a tens and a ones value for each number, and we're going to put them together. We're going to use the all total strategy, then we're going to use the expanded strategy. Then I'm going to show you a proof picture, and my proof picture is going to need to match and demonstrate what I did here and what I did here. When we're done, you'll find that the sum is the same. Our answer will be the same for here, and in our proof drawing. Let's put a little mark right here for where our proof drawing is going to go. Okay. So there's three things we're going to do in this video today. You will not have to do all three of these for every problem in your homework or in your classroom. You will always do this, and then it's your choice to pick if you like to use this strategy or this strategy. Whichever one fits your thinking better, your brain better, fits the way you understand numbers better, feels easier to you, is fine. And then you always will do a proof drawing to go with it. Okay? Here's our two numbers. We can write our math problem like this. We can also write it horizontally. Either way, we're writing the same thing. 43 plus 39 is equal to. This is horizontal. This is vertical. Horizontal means laying down. Vertical means standing up. Either way, we're going to be doing the same thing. We're taking 43 and adding it or putting it together with 39. Together will give us a total, a new total. Okay? Let's start with our all total strategy and take a look at that first. With all totals, we're going to always start with the most powerful place value. So when we look at our problem, we can see that we have tens and ones, and down on this number we also have tens and ones. So when we consider which one is our most powerful place value, we know that tens is bigger, more powerful, has more value, means it's more than the ones. So we're going to come over here, we're going to write our problem, 43 plus 39. In the all total strategy, we start with our biggest place value. We know our biggest, most powerful place value is the tens. So we're going to look at just that part. I'm even going to take a board and I'm going to cover up so that I only see the most powerful place value, which is the tens. So I have 4 tens plus 3 tens. I can use my touch math because we want to try not to use our fingers in second grade. We really are ready to use a different way, either mental math strategies or touch math strategies. 4, 5, 6, 7. So I know that 4 tens plus 3 tens is equal to 7 tens. 7 tens is the same as 70. We've been practicing that 3 tens is 30, that 2 tens is 20, that 8 tens is 80. We know that 4, 5, 6, 7 tens is not 7, it's 70. So we're done with the tens column. Now we're going to go to the weakest place value, which is the ones. We're going to cover this up just like we did before, so we're only looking at the ones place value. We're going to use our touch math again. When we use touch math, we are going to put dots, touch math dots on the smallest number, the one that is less. we're going to grab the big guy, 9, 10, 11, 12. 9 plus 3 is 12. And we know we're talking about ones, so it really is just 12. So we had 70. Now we're going to add 12 to it. Now I need to go down here and finish my problem. I have 7 tens plus one more 10. 70 plus another 10 will be 80. 2 ones plus 0 ones is 2. So my total is 82. I'm going to come over and do a proof drawing, and let's see if it matches our sum from over here. I had 43, 10, 20, 30, 40, 41, 42, 43, and 39. 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. I'm going to show how I'm putting those sums together. I'm going to look at my ones and see if there are enough to make a 10. It looks to me like there's enough to make a new 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to hook them together. There's my new 10. Now I'm going to count it out. 10, 20, 30, 40, 50, 60, 70, 80. 8 tens means 80, 81, 82. My proof drawing shows a match for my total as the one I did with the all total strategy. Now let's take a peek at what it would look like if we did the same problem with the expanded strategy. I would take my problem, 43 plus 39, and I would break the numbers into expanded form. I know that 43 is the same as or equal to 40 plus 3. I know that 39, if I stretch that number and break it apart and talk about what it's made of 30 plus 9. See how I've taken those numbers and stretched them apart? Now I can use what I wrote about the expanded forms to put them together by tens and then by ones. So I'm going to actually turn this part into a problem. 40, or 4 tens, plus 3 more tens is 40, 50, 60, 70. Plus, now I'm going to add my ones, start with my big guy, put my dots on the little one, 9, 10, 11, 12. Now all I have to do is put 70 plus 12 together. When I look at 70 plus 12, I know that this is the tens and the ones, tens and the ones. I can hook my tens together. 7 tens plus 1 more will give me 8 tens. 0 ones plus 2 ones will still be 2 ones. My total using the expanded strategy was 82, and it matched my proof drawing I did earlier right here. Because I know how to do a strategy and a proof drawing, I can show that I fully understand my problem, that I fully understand how I got it, and I understand what happened to the numbers to get to the answer. That they were going together, they were getting bigger, that some of the ones, there was enough ones when I put those two numbers together to make a new 10, and when I added and counted the new tens and however many ones were left over, my total was 82. Again, very different than the way Mom and Dad learned how to do this kind of math, but we are asking kids to show and demonstrate a deeper understanding of the process, not just following a series of steps that don't have meaning.